Alright guys, so let's take a look at our homework for tonight on number 1 through 4. They're talking about inverse variation and then a quick substitution step. So remember, our direct variation was y equals a times x, and our inverse variation is y equals a divided by x. So in each of these cases, we need to come up with this constant of variation, this one right here. So the plan is to multiply both sides of this equation by x. When you have an x in the numerator and denominator, we can make that go to 1. And over here you'll have a equals x times y. So really, what this is saying is if I multiply x and y together, I will get this constant of variation in my equation. So we can have y equals a over x, and 7 times 2 is 14. On the next one, they're going to have me multiply 9 times 13 and then divide it by 3. Before I actually divide, I want to simplify my terms. 9 divided by 3 is 3. And 3 times negative 13 is negative 39. Negative 6 times 5 is negative 30. And in this function, again, before you multiply, it's best to reduce your terms. 8 divided by 2 is just 4 divided by 1. So we can see here that y is 4 over x. The very last thing they asked us to do is go back into all of these equations and substitute in a negative 2. So if I were to put a negative 2 in here, into substitution, I would have 14 divided by negative 2, and this gives me negative 7. So y is negative 7 when x is 2. If I put a negative 2 down here, this is an odd and this is an even number, so we should be done with our equation. But we do need to remember that a negative divided by a negative will give us a positive. So this should be y equals 39 over 2. In our bottom equation here, we're going to divide by negative 2. Again, a negative divided by negative is a positive. 15 divided by 30 divided by 2 is 15. Our last equation here has us dividing by negative 2. 4 divided by negative 2 is negative 2. On 5, 6, 7, and 8, they're asking for translations of the graph. We know that k out here is up and down. We know that h over here is left and right. From 0, 0, I will first look for my new asymptotes. I have one here and one here. Now that I have my new asymptotes written down, I can see that the first thing that will happen is I will shift down 3 units. Down 3 units means minus 3 for this k value. Then I see that I shifted over 2 units. Over 2 units means that this x value down here, this h value down here, a negative and a negative will be a positive. Alright, so now we know the value of each constant, h and k, is positive, negative, and 0. This one is negative, and this one was negative 2, because a negative and a negative will make a positive. And that's the pattern that we're going to use for the rest of our equations here. We want to start again at our origin 0, 0, and then draw in the new function asymptotes. From this one we can see that we actually went up 4 units. So plus 4 can go on the end of our equation. And then we went to the right 1 unit. So right 1 unit, be like this, because a positive and a negative is still a negative. So that's our final equation. Let's move on to number 7. Again, we can set our asymptotes up exactly where they should be, in the center of our functions. We're going to look at 0, 0 here, and then our new asymptote cross, which is down here. Actually, the only thing that happened here is we translated down 2 units. So we're going to have y equals, this is 1 over x, because there was no left and right movement. Y equals 1 over x, and then we went down 2 units, so minus 2. In number 8, here's our original, the origin. We can quickly come in, sketch in our asymptotes. Now we know where the new function, there we go, that's better. Now we know where the new function is going to cross. This means that we are going to go down 2 units, so I'm going to put down 2 units. It also means that I need to go left 2 units. So I'll go left 2 units. And remember, a negative and a negative is a positive, so we're going to put a positive down here. This is y equals. Alright, left 2 units, down 2 units. Now, of course, these numbers on top, these are vertical stretches, and depending on your coordinate points and how far this has been pushed out from the origin, for example, this one is really clear to see, that there's been a vertical stretch in some way and moved out. Alright, number 9, asking us for performing the indicated operation. So what we need to do is, just like we did up here, reduce all of our terms as much as we can, and then multiply. Alright. So I see a 3 and a 6 here, and there is, if I divide by 3, this will be 2. So I would have x cubed times 4y to the 5th divided by y squared, and divided by 7x to the 4th. Alright, let's keep going. I have 4 on the top and 2 on the bottom. 4 divided by 2 is 2. So now I have x cubed times 2y to the 5th over y squared times 7x to the 4th. Remember, when I'm dividing like bases, I can subtract my exponents. So I have 3 on the top and 4 on the bottom. That means the power of 3 will go away here, and this will go 4 minus that power. So it will just be x to the 1st. The same thing will happen over here with my y values. Because I'm dividing like bases, that means that I can subtract my exponent. And 5 minus 2 is 3. So this will go to 1, and this 5 will come to 3, because 5 minus 2 is 3. So now it's just a matter of us writing out our final answer. 2 y to the power of 3 over 7 x to the power of 1. Alright, let's take a look now at number 10. Number 10 just has an x squared and an x minus 2 on the left-hand side. On the right-hand side, we're looking to factor our quadratics. On the numerator, I will factor 2 and 5. 2 times 5 is 10. If 5 is positive and 2 is negative, 5 minus 2 is 3. So these are my factors for x. On the bottom, they have a common factor of x, and what will be left is x plus 2. X times x is x squared, x times 2 is 2x. So now let's reduce our terms. I have an x minus 2 and an x minus 2. Again, when I'm dividing like bases, I can subtract my exponents. So 2 minus 1 will be 1, and this x will go away. So at the very end, I have an x and an x plus 5, and then I want to divide that by an x plus 2. These are the parts that are left over. We know that x can't be 0 and plus or minus 2 here. All right. Now we are on to x can't be 2 or 0. The terms that we cancel to 1 show up here in the bottom as what x could not be. All right. Number 11. Number 11 is more factoring. My factors of 6 are 2 and 3. And I'm looking for them to add up to positive 1. So 2 times 3 is 6. And if we make 3 positive and 2 negative, we'll have it. On the bottom, my two factors for 14 are 7 and 2. And I'm looking for them to add up to 9. So I'm going to have x plus 7 and x plus 2. 2 plus 7 is 9. All right. Excuse me, I misread the sign here. I thought this was going to be multiplication. This is actually going to be subtraction. So we're still going to factor just to see if there are any terms that we can take out. And it looks like there might be minus 8 over x plus 7. Okay. So now we get to use our formula A, D, B, C, C, D. That's AB minus BC over CD. If we're more visual, we can say that this is the left wing, the right wing, and then the denominator. Multiply it together. So on the top here, we're going to have x minus 2 times x plus 3 times x plus 7 minus, that was our left wing. Now let's do our right wing. Right, we have 8 times x plus 2 times x plus 7. Now we need to divide that by our base. Our base down here will be x plus 2 times x plus 2 times x plus 7. Now instead of just matching 2 numerator and denominator, we need to match all 3 terms. If all 3 terms have the same factor inside of them, we may close that to 1, but that's the only time that that will happen. Alright, so from here we can see that our x plus 7 factor will close out. And our other factor to close out here